So far we've studied many kinds of different series. We've had infinite series, which we'll still have, but we've got geometric series, series. What we're going to be looking at now is power series. At the end of this lesson, you'll be able to recognize a power series. All right, a power series centered at C is a series of the form. You'll look at this form right here. We're going a sub n, x minus c to the n, where a sub n are constants. You'll notice this looks a little formal, but basically what's going to be happening, we do have something to a power of n, and remember that n is our variable, and then we're actually going to have an x in the problem that can be changing. So it could be 5, 2, -7, 1/2, whatever, as we're doing this. So what we are going to do, if I looked at n equals 1 to infinity of the series x to the n, if I plugged in 1, I'd get x to the 1, and then plus x to the 2, plus x to the 3, plus x to the 4, and so on. So that's what we would have. Now keep in mind that the x could be any number. It could be 5 or -2 or 1/2. So based on, if I looked at this and I was trying to decide whether it converged or diverged, I'd have a little bit of a problem because I don't know what x is. And based on what x is, the problem is either going to converge or diverge. And just like I said, a power series may converge for some values of x and diverge for others. So I'm going to keep that same example going here. Went from x to the n. If we had x equals 2 as the x, this is what the problem would look like. Would be 2 to the n, and you'll notice if you looked at this, this would be a geometric series because we have something to the nth power, and since it's a geometric series, our r would be 2, and since our ratio is greater than 1, we would have to say that this series diverges. Okay, and then if I picked x equals 1/2, so if I did that same thing in this time, we put in 1/2 for our x, we'll have 1/2 raised to the n power. It's still a geometric series. This time our ratio would be 1/2, and since our ratio is less than 1, our series would converge. So we're actually going to have a problem with this because we can't just say the series converges or diverges. What we're going to do is say which values of x does it converge for and which does it diverge for, and that's going to lead us into if you were looking at this, if you can think about what would the radius have to be, the ratio have to be for this to diverge, to converge, it would have to be anything between -1 and 1. So we'd write something like that. And the way that I would put this, this is actually going to be something that's called the radius of convergence. Not the radius of convergence, the interval of convergence. So that's how we will denote, and so that's where it would converge for. And then we're also going to have something that's called a radius of convergence, and to get the radius, you're just basically going to take the right point of the interval minus the left point of the interval and then divide by 2, and so the radius is going to equal 1. So those are the two things that we'll be doing with power series. We'll find out the interval of convergence, for which x values will the series converge, and then we'll be finding the radius. So hopefully now you're somewhat familiar with power series.